Chemical reactions in aqueous solutions are among the most important classes of chemical reactions. In this video, we briefly introduce ourselves to aqueous solutions and consider how we represent dissolved substances in aqueous solutions. You may recall that a solution is a homogeneous mixture of two or more substances. There is only one visible phase present, and the mixture is uniform throughout, meaning a subsample taken from the mixture would be representative of the whole sample. Solutions are comprised of the solvent, which is a substance present in the greatest amount by moles, and the solutes, which are all the other substances present in the mixture. The solutes are said to be dissolved in the solvent. Aqueous solutions are homogeneous mixtures where water is the solvent, and would be very familiar with, for example, dissolving table salt or sodium chloride, NaCl, into water to form an aqueous solution. We can represent this dissolution process here with a chemical equation showing that solid NaCl, or solid sodium chloride crystals, can be added to water and transformed into the dissolved form of sodium chloride, where it becomes a solute in an aqueous solution. Aqueous solutions are so important in chemistry, they are given their own subscript, the AQ subscript, which indicates that the particular substance represented in the chemical equation is present as a dissolved solute in water. At this stage, we should note that dissolving a salt like sodium chloride in water is considered a physical process where no new substances are formed, and the solid salt and pure water are easily recovered by simple physical processes such as evaporation or distillation. We should also note, however, that not all dissolution processes are simple physical processes, and many actually involve a chemical change where new substances are formed, and we'll see examples in later videos. There are many different types of aqueous solutions. For example, we can have solids dissolved in water, such as the salts that are dissolved in water that make up seawater, or the solid caffeine that is dissolved in water that makes up our cup of coffee. We can have liquids dissolved in water as well. For example, acetic acid is the main component of vinegar, and like water, acetic acid is a liquid at room temperature and pressure and is dissolved in water to make up the vinegar solution. Alcoholic beverages, for example wine, have liquid ethanol dissolved in water. We can also have gases dissolved in water to form aqueous solutions. For example, oxygen is dissolved in natural water bodies to allow fish and other marine organisms to respire. In a following video, we explore aqueous solutions in more detail by considering the properties of electrolytes, substances that dissolve in water to produce solutions that conduct electricity, and non-electrolytes, substances that dissolve in water to produce solutions with poor electrical conductivity.